turn that on. Okay, the other components you'll need is you need one LED. Okay, so the LEDs are the little sort of colored tops with 2 pins coming out. One's long and one's short. Okay, and the last thing you'll need is, sorry, the second last thing you'll need is a resistor. So the resistors are the little knob things. So if I quickly show that, it might be difficult to see. But you can imagine that each of the resistors looks something like this. I know it's very small, but the resistors have a little blue color to them and have a couple of stripes on the top of that. And you should see it has a long length. Okay, you need one of these resistors. Okay, it's very small in my hands, I know. And lastly, you'll need some jumper leads. Now, sometimes those jumper leads are very fiddly to come out, so you need to sort of wiggle the cable out. It is possible to get them out. If you are struggling, we can get some, I'll get some help volunteers to help cut everyone's zip ties out. But it is possible, trust me, to pull them out. It does take a little bit of wiggle. It is done pretty tight on those kids because they're brand new. Okay? Can you just run me? Yeah. Let's install that real quick. Alright, is everyone ready? Doesn't matter which cable. Either cable works fine. Oh, that's right. I've been recording.
Yeah, you've been recording.
I've been recording.
I streamed as well. The stream is now live.
Oh, the stream is now live. Awesome.
Yeah.
Okay.
Right, so it's on now.
Yeah. Alright, cool. Just flip back to the slides. Okay, so just for context, we're going to be making this thing right here. So I'll just make this not so big. We're going to be building this circuit here on the screen. Okay, can everyone see? It is a little bit fiddly, okay, but I need you to recognize some things, okay? You'll notice that the LED, so the LED emits light, or it's called a light emitting diode, okay? And diodes allow current or electricity only in one direction. So we have to make sure that the direction of power through the LED is correct in order to show any light, okay? The way to tell on the LED, you'll notice that on the sort of grid, underneath the light bit, the colored bit, you'll notice there's a little flat section, okay? Right? And so you can see that the sort of direction. The way to tell that is by looking at the pins of the LED. The long pin is positive, and the short pin is negative. Okay? Keep that in mind as we make the circuit. What we're going to do is we're going to wire this up such that there's going to be, we're going to send current through this wire from pin 13, right, around towards the positive end of the LED. Then from the negative end, we're going to connect it to a resistor, ignore that. And then from the resistor, it's going to go back to what's called a ground. Okay, and ground is where all the current goes and evacuates. Okay, so let's quickly do that now. Are we good to go?
Yeah.
The last one works. It actually works?
Yeah.
Cool.
Live.
Oh. Radio. Okay, so if you guys want to take a photo, reference the slides as you go along and do this, okay? I'm going to switch this view over to my webcam, okay? So you guys can see me sort of building the circuit together, but if you really need to, take a photo right now as reference or refer to the slides that should be linked on the event page, okay? I'm going to flip the slides in about 20 seconds. I need to set up the circuit.
Alright, I'm going to have, there's one set of cutters going around the cut cable ties. So just throw it around.
Oh yeah, can you freeze the screen? Just like,
What?
stop extending the screen to the Is that
It's not extending the screen. Why?
like freeze the screen so that it just stays on the screen? Or do you need to change
No, I need everyone to see this. Yo.
The live stream is something.
Huh?
The live stream is.
Oh. We're showing this. No, we can't. I don't want to face down more because it's going to tip. So that's fine, right? Everything needs to happen in this domain right here. And we're good. No, it's okay. That's fine. It's gonna tip.
People are struggling to look at it.
It's gonna tip a little. So
Is that good?
yeah, maybe. I'll work off that.
I think that's good. Okay.
As long as I know my workable area, which is gonna be
These cables.
start 1, 2, 3. All right. So if you haven't already assembled that circuit, I'm about to show you how to do that live. Okay. I note how I have. So can everyone see the screen and my hands? My hands are not pretty. We need to show this. Okay, this is an Arduino Mega. It's slightly bigger than what you guys have there with the Arduino Unos. But what you need to know is that the pin configuration and the way we treat the pins is the exact same, right? So pin 13 on the Arduinos will correspond to my pin 13. So don't worry, you're not missing out on anything. All right, so let's make a start, okay? So we need an LED, which is right here. Okay, hopefully you guys can see that. We have a wire. Okay, this is a jumper wire. We need a few of those. I think we need 2 or 3 of those, so keep on tight with that. You need your breadboard as usual. I'll keep that nice and in the screen. And lastly, you'll need your Arduino board. Okay, we'll deal with the Arduino board last. Let's sort out the breadboard first. So if I center this on the screen. Your Arduino, note how I've bent my... Oops, I've just dropped that. Note how your Arduino has a long and short end, okay? I'm going to try and represent this as clearly as possible, but you'll notice that on my LED, I've bent the long leg, okay? And this is just so that the 2 legs are of equal length when I insert them into the breadboard, and that ensures a much more secure connection, okay? You don't have to do it, but it's a nice move to make to ensure that the LED syncs on correctly, okay? All you need to do is put the put the LED on 2 separate pins. Okay, so I'm just gonna plug them in like so. I'm gonna plug it in like this, okay, on 2 separate vertical rails. Okay, it's not that hard, right?
People on the back can't actually see John. Do you sure you don't want to do the switch screens? It's. I can't get it to work. I just did. Oh, I said it should work. Do you want to try?
Yeah, try it. Okay. Next thing is, what are you gonna do? Are you gonna mess with the lights? Mind if I finish this one first?
You do that.
Right. So next thing, right? We're gonna plug, and I'm gonna get a different colored cable. I'm gonna get black, and we're gonna get maybe a purple one. Okay.
Where's the cable that comes out of the board?
None. From memory. All right. So I'm going to get a different colored cable. Remember that we're going to connect our short end to what's known as ground, electrical ground, okay? So the short pin on your Arduino, so I'm going to plug it in the same vertical rail. You notice that they're on the same rail, they're on the same vertical rail, but they're not in the same socket, right? And they're still electrically connected. I'm now going to connect this one to the blue rail, or negative. It's marked by a minus sign, and that's the negative ground rail, okay? So you'll get an LED, right, plugged in long end, short end on different vertical rails, and then a wire that connects from the short end down onto the negative end. It's on here. It's on here. So just scroll down a little bit and then show the key. Alright, next thing we're going to do, grab yourself another 2 cables, and now we're going to connect this circuit to our Arduino. Are you guys ready? Yeah? Alright, so grab you guys aren't ready? Well, we got half the circuit out. So, do you want me to repeat it quickly for you guys? Yes. So it's going to be plugged on the short end. So plug it in the same vertical column, but different socket. Yep. And then the next one is going to go on the blue rail or the negative ground rail. Okay?
Same row?
No matter where position, remember that they're all connected on the blue rail, right? So it should still look something like this. I know it's a little bit blurry. This camera's not the best. I'll try and upgrade it next week. Next thing. Okay, so Now we're going to connect that blue ground rail to the actual ground of the circuit, which is on your Arduino. So let's plug one end of your cable. I'm going to get a black cable because it usually represents ground. Doesn't matter which one you use though. Let's plug our negative cable. So I'm going to plug it anywhere on the blue rail. So I'll plug it on the very end. It doesn't matter. Anywhere on that blue rail. And on the other end of this, we're going to grab our Arduino board. Okay, and we're going to plug this into, you'll notice that on your board, remember how I was saying there's these power pins, right? The power pins correspond, there are some G and D pins, and these are known as electrical ground, okay? And electrical ground just means that all the current is going to evacuate through there after they've been used, okay? So let's plug that into here, so into the ground pin. So remember that that configuration is slightly different for you guys if we're in a different spot, but it's from the blue rail of the breadboard to the ground pin of your Arduino board. Okay? Any ground pin, there are two, any of the two ground pins. Okay? Remember that if you need help, we still have a couple of volunteers around. Okay? Put your hand up and get some help. There are two. Any of the two ground pins. Why is it playing? Okay. Remember that use the volume button. Alright. Our live stream's working. Thank you. Alright, cool. please don't laugh and please. Okay, good. Alright, so the last cable we need, okay? The last cable we need is to connect the positive end of our LED to pin 13. Okay, we're not connecting it to power yet, connecting it to pin 13, and we're going to remotely control the power on pin 13, right, with our program that we're going to write very soon. Okay? So, you're going to connect on the same vertical rail. Okay, I know it's a little bit blurry, I'll try and make it a little more focused. On the same vertical rail as the positive or long pin of the LED to this cable, like so, okay? To the same vertical rail as the long pin, and then the other end of that cable will go to pin 13, okay, on your Arduino board. So let's do that, okay? Once you plug that in, that's your entire LED circuit done, okay? And this is the first of the circuit you'll hopefully have built. Actually, I forgot one thing. I forgot the resistor. Because genius of me, I forgot the resistor. What we need is actually a resistor in the circuit, because otherwise the LED will actually burn. It will actually light in the, not really burn, but it will actually break. So what we actually need to do, I completely forgot, I'm so sorry. But if you reference this diagram here, okay, and remember that this is what we're referencing on. So hopefully by now you should have the pin 13 to the long pin, okay, the short pin and the ground. What we need to do is add this resistor, because otherwise the LED will actually burn. What the resistor does is ensure that not too much current goes through and make sure that the circuit is actually workable with that LED. And so what we need to do is we need to actually chuck a resistor in between your hopefully ground cable here and LED. So I'm about to show that on the live stream here. Yeah. Awesome. Sorry about that. So we'll chuck our resistor. What I've done is I will actually put one end of the resistor on the same end as the short end of the LED, and the other end of the resistor to the cable that connects to ground. So remember that this yellow cable was what I connected to the blue line, okay? And so I'll connect the other end of the resistor to the end of that cable, okay? Like so, okay? If you ever get stuck, remember, put your hand up, yes? That is a resistance, yes. Yep, so sorry, I made a mistake. So this one goes here. And we plug a resistor that goes between this one and this one. So between those two rows, yeah? Okay? So what you should get is, I'll put up the diagram because it's much easier to see. Yes? The resistor on the other end goes towards this area. connect that resistor. Right. Realize that each number corresponds to so these to these two. Is see how these are grouped, so that's one. This needs a resistor. So that's one. Check a resistor between this one and there. Yes. And then one end goes to the other. Yes. Okay. Anyone else having problems? I'm gonna quickly run around. Yes. Missing one step. This one is yes, it's so remember it's the pin 13. Look at the diagram. Pin 13 goes to the long end of the LED. Then the short end of the LED goes to the resistor. The resistor goes to ground. And ground is this long blue line which is connected to ground on the Arduino. Okay? Anyone else need help? Up the front-ish. Yes. Is there no green light in your kit? There is a green light. Oh, that's unusual. I'm not sure. I don't think that's going to make a difference. It shouldn't show red light, it should show green, unless there's an error. I'll have to double check that. No, I don't think that's broken. Yes. Yep. So, long pin here is what goes into 13, long pin, short pin, resistor. Resistor goes here. And this one is there. There you go. That's it. Yep. It's not going to burn the resistor. Yeah. Any of the three resistors, but the resistor goes from the short end of the LED. So between this one here. So this one, these two ends, so this resistor and this one, right? Now need to draw together. This resistor, this cable now needs to draw together. Yeah, so connect them together. No. So, look at the diagram there. Positive is off, so that will actually go to this one here. So it's not positive now. Is it? Sorry. Then the short end, resistor, comes out of that. How do you need to know where? How do you resist there? As long as it connects to the short end of the resistor. Right? Oh, yes. It doesn't matter. Yes. Sure. Yes, that's correct. We're going to program that in a moment. Alright, so anyone else need colors for their wires? I'll show you that in a little bit. We're just setting up the socket. Unfortunately, you're going to have to figure out a way. Yeah, you can. Please watch this here. Alright, so anyone else need side cutters to cut their wires? Alright, cool. So, hopefully what you'll notice is the moment you plug your Arduino in, it's already started to blink. This is a default program on some of your Arduinos, not all of them, okay? And if it's not, don't panic. Let's test whether the code actually works, okay? And once the code actually works, then we will fix your electrical circuit if it's still having problems, okay? So let's move on to programming it. All right, so jump on your Arduino IDE. You'll notice that mine just installed. So we'll type Arduino and hopefully it'll come up. So run your Arduino program and what should pop up is the following, other than maybe a Java request, which will allow. Okay, so what will show up is what's called the Arduino Integrated Development Environment, okay? This is where all the programming is going to happen. Okay, you'll notice that the font is quite small. I'm about to make that a little bit bigger so all of you can see that. So if you just give me one moment. Here we go. We'll set that to 24. Is that code big enough for everyone to see? Yes? Can everyone read that? Is anyone still not able to read that? Bigger? Alright, let's make it even bigger. Rightio. So let's make that 30. Hopefully that's big enough for everybody. Is that big enough for everybody now? Damn it. It's okay, we don't have too much programming today. Let's make it 36. Come on, surely now, I can do enough. We're not going to fit everything on here. Is that big enough for most people? Within a reasonable standard of presentations. Cool. Alright, so, guys, if you guys could just lower the volume just a little bit, because I'm going to run through how we're going to program. Is that cool? Everyone up the back? Alright, so, to actually program the Arduino, we're actually going to need to go through 3 steps, and I'm going to teach you everything you need. And what we're going to do with this program, besides, if you haven't already, plug your Arduinos into the computer, what we're going to do is we're going to do exactly what some of your Arduinos might already be doing if the circuit works, which is it should just blink. Okay? And this is the very first program that we make, but from there it really opens up all the opportunities that you could really think about. Alright, so I'm going to try and type one-handed, so hopefully all of you can beat my typing speed with one hand. Okay? So, here we go. What we need to do is... Sorry? Okay. Yeah, I'll bring the window in. Just a moment. And you'll see my emails there. Alright, is that better? That works? What about the right end? Is it cropped off? Right end's also cropped off. Awesome. This is always good. Cool. So, okay. So, there are 3 parts that we need to know about programming an Arduino, right? Usually it boils down to 3 main steps. The first is what we call defining constants, okay? And this is just some programming 101 that I'm not going to go too deep into, okay? But what you need to know is that constants are values that stay constant, right? And we define this at the beginning of our code. And the reason why this is important, right, is because say I need to reference that same number multiple times. Instead of typing that same number multiple times, I can refer to the constant, and anytime I should change that at a later date, I can just change the constant and not the number on every instance. And this will become apparent not in this first program, but in future programs. It'll get very messy if we don't do this, so I'm actually going to teach you some good fundamental programming from the very beginning, right? What we're going to do to define this constant is we're going to use what's called #define. Okay? You'll notice that as soon as I've typed define, the text turns green. It turns some olive green, and this means that it's a recognized command. Okay? What we're going to type in here is our constant name. In this case, my constant name is going to be, well, let's think of a creative name, right? What kind of creative name can we use to describe the pin of an LED? Let's think for a minute. What about cute dog? Alright, cool. So we have our name for our LED pin called cute dog. I'm just joking, we're going to change it to LED pin. Alright, so we're going to change it to LED pin. Okay, and this corresponds to the signal pin for our LED which we're about to program, okay? And what pin did we just plug our LED into? 13, right? You guys hopefully remember plugging into 13, which means that we're going to send our signal through pin 13. And so I'm going to specify that we're sending it through pin 13, okay? As with any general programming, you should always finish your any command with a semicolon, okay? And that's just the key located to the right of the L key, okay? Great. So we have defined the LED pin that we're programming from. Next is what's called void setup. Okay? Void setup corresponds to, void really just means a function. So let's not worry about that for a moment, but you do have to type it. Setup just means that this section of code, as is described already by that default comment, anything inside the setup function is run once. Okay? That means that when Arduino starts, as soon as you power it or as soon as you reboot it with the new program, the very first thing it will do is it'll scan top to bottom and it'll run setup once. Okay, so it's run setup, and obviously it's there to set up your program, from which we enter the second stage, which is just called the loop. And what happens in loop is it repeats whatever's inside loop infinite number of times until the Arduino loses power or something goes wrong. Okay? So what ends up happening is we define our pins, we set up our program, and then we loop however many times we like. Okay? And that loop runs on infinitely until we lose power. Okay? And that's where your main program will go. There are obviously other functions you could make yourself, okay, outside of void setup and void loop, but we won't go into that. That's too complicated. Let's just stick with our basic 3 sections. Okay? What I need to do next is tell my Arduino that the pin that I've just plugged in, my LED, is an output, right? Because remember how I said at the very beginning, we need to identify inputs and outputs and how that makes basic robotic systems. Well, our Arduino needs to know whether it's an input or output to know whether to read or to write signals to that pin. So that's what we're going to do in our next section. Inside void setup, if you would like to follow me now, okay, what we're going to type is we're going to define the mode of our pin as an output. And so the command for that is pin mode. Just type exactly in that way. And you'll notice that, like the define function, it turns orange. Actually, no, wait, that's not green. But yes, it turns orange, right? Which is another command that is recognized by Arduino, and that means we've typed it correctly. Okay, it's typed in this exact format, I believe. Okay? Inside pin mode, there are 2 input statements that we have to make. The very first one we're going to specify is what pin we're declaring. In this case, I'm declaring LED pin 13, right? But instead of writing 13, we've already defined a constant to do that for us. So LED pin. Okay? 1, 2, 3. Okay? The second input it needs is whether it's an input or output, right? And we can specify that by simply writing output. So if you, all caps, just write output, you'll notice it turns blue, right? Which is its own identifier and a different funny thing. But what you need to know is that now we've declared our pin 13, our LED pin, as an output. And obviously, as I said before, finish your line of code with a semicolon. Okay? Yes. Lastly, we're going to go into our void loop, right? Which is where our main program is going to happen. So, what I want you to do is, let's jump into our void loop here, and I want you to type what we're going to do, what we're actually going to do in our program, which is going to send a signal, send some power to the LED to turn it on. Okay? And this is what really boils down the basis of any robotics project, is we're sending power to necessary components to control where to go and so on. Right? We're reading signals and we're reading electrical voltages from other sources, from other sensors, and we're outputting it through some own independent voltage, right? So here, we're going to actually write a digital signal to our LED. And then the command for that is digital write. I believe it's spelled like that, yes? And you notice again it goes orange, okay? Which means it's a recognized command. You should always ensure that it's orange, otherwise you've typed it incorrectly in some way. Check your spelling here, but that's how it should turn orange, okay? Next thing, after we've written that, we're gonna obviously put in our inputs to that command. Okay, I'm gonna finish with brackets and a semicolon first. We're gonna specify which pin has the output. So does anyone want to tell me what I'm gonna chuck as my pin number? LED pin, right? LED pin. Remember, it's not pin 13, but even though that would work, I want to reference the constant that I made at the very beginning in case I want to change that. So, we'll type in LED pin. Okay? The next thing I need to input and the last thing we need is what kind of signal. Now, hopefully you guys remember in the slides we had low and high signals for 0 and 5 volts for our digital signals. So what kind of signal do you think I'm going to put in here? High, right? So we're going to put a high signal into here because we're going to write that to the LED. High, okay? And that's it. This is your program actually complete, as long as you have all the correct formatting and so on. Yes?
In LED, between LED pin output and LED pin high, is that a space or a pin there?
The space, it's a space, it's not necessary. The code will actually ignore the spaces. I'm doing that so that you can easily see and it looks nice and pretty. Okay? One last thing actually, every piece of sample code for each of these workshops will actually get released later tonight. So if you at some point forget or you forget how to do things, I have already written that up and I'll upload that as well. Okay? Right, so we have that program going. What we do now is we upload our code to the Arduino. So the way to do that, if you aren't like me and have been prepared, you would have already plugged your Arduino into your laptop, like I am doing now. All right, cool. So I'm going to have a run a little shift. Peter, can I get some help? Can you shift the camera onto the left-hand side of the computer? Yes. Awesome. Not enough cable. Yeah, I'll do.
Frozen up there.
Is it? Because it's bent.
Whose camera is this?
This is ours. Right.
Oh, it's the delay.
Yes, there is. Okay, so what you need to do is just, with my one hand awkwardly, it's all good. You should plug your Arduino in and it should fire up. Okay, here we go. Okay? Oh, that was so laggy. We're going to plug your Arduino into your board and you're going to hit the... Did that screen just fail on me? Why? Hang on. There we go. Alright, so the next thing you're going to do is you're going to upload your code onto the Arduino. So, we're running out of time, but here we go. Upload on the top left-hand corner. You're going to hit upload and it's going to ask you to save your sketch. Now, your sketch is just the piece of code that you have, so just chuck it on your desktop and give it a quick name like LED Blink, something like that. Okay, so I'll do that here as well. Desktop LED Blink. Okay, 1. Cool. Press save. And now what it should do, if it's right, is it will give you an error message because I made a mistake. Because classically, every workshop first time around, I'm going to make a mistake, right? What has happened is it will tell you anytime it gives you an error, okay? Before it uploads, it always does what's called compiling, which tests that your code is actually functional, right? That the Arduino can actually run your code. And in this case, what I've done is it told me that it's expecting some sort of closed bracket. Right? And obviously you might not know what that means, but you can Google search that. And the solution is that we actually, for the first line of code, delete that semicolon. Right? And I intentionally left that in there. I didn't actually make a mistake and then fake it. But I want to show you that there is an error system on here to ensure that if there is something wrong with your code, it will jump that error out of you. It will tell you exactly where that is in the copy error messages here. Okay, it will tell you exactly what's wrong with your code, at what line, and you can Google search the error and figure out why. Okay? Also a good check for your code. Right, so let's re-upload that now. So just press upload. And what it should do automatically is upload straight to your board. Now, if that doesn't happen for some reason, I'm going to show you why. Okay? What you need to do is chuck on tools. As you can see, it tells me it couldn't find it. So you hit tools, board, and you notice there's a long list of boards because Arduino is an open source platform, right? What we're going to do is we're going to select the Arduino board that corresponds to what you have. In your case, it's called the Arduino Genuino Uno. Okay? It's really hard to pronounce, I'm sorry. Right, but you're after the Uno, okay? So click on the Uno for that board. I'm going to click the Mega because I have a Mega, but if you have an Uno, please click the Uno, okay? So I'm going to click the Mega right here, which I can find. So in Tools, Board, and the Arduino Mega, okay? And you notice that's been selected, and then you're going to select your port, okay? And port just corresponds to the USB output that your laptops have. Okay, so you're going to make sure that you select the right serial port that corresponds to your Arduino. So say the brackets name of the Arduino board. In my case, it's COM4. Yours might be different. It doesn't matter. As long as it says Arduino in it, that means you're on the right track. Okay, unless you have two Arduinos plugged in, in which case you probably shouldn't be here because you're too good for us. Right, so COM4. We've selected that again, and now we're going to upload our board, upload our program once again. And you'll see down here that it says done uploading, okay? Done uploading, right? What should happen, hopefully, if you've uploaded this code correctly and your circuit's all well and good, your LED should be exactly like mine is on the live stream. If you can see it on the top left and top right, my LED is just on. It doesn't actually blink, it's just on. And we're about to get onto that blink now, okay? Is it fully on? Who has the LED fully on with that uploaded code? A lot of you? Yeah? Who's struggling to get that LED fully on? Yes? I'm going to fix yours. Is it fully on? Oh, no, it's all good. Yeah, so who doesn't have an LED that turns on with this code? You good up and now? You're good? Yep, there you go. Okay, anyone else? Yes, up back there. Yes. Alright, does anyone else have issues with the LED not turning on with this code? Alright, so I want you guys to all think now. Remember that I was saying how your first program should be to make the LED blink. And hopefully you'll notice by now, and hopefully I'm not too stupid, but you'll notice that the LED is not blinking. Right? What do you guys think is happening and why that Arduino is not blinking? Can you guys see? Yes? Right, it's only turning on high. We have no command that turns it off. Right? At this stage, we've never told Arduino to turn that LED off, so there's no way it's going to be able to blink. So, hopefully you're thinking now, we're going to think of a solution here, and we're going to we're going to write a digital signal to our LED pin, and that should be in all caps, sorry. LED pin low, right? We're going to set a low signal to that LED. And I want everyone to type that in, and I want everyone to re-upload that and see what happens to the LED. And if anyone has a blinking LED after uploading this code, let me know. If anyone has a blinking LED.
Isn't it like it's too fast, so it won't actually
Workshop, can't swallow it. Right, so, yeah, if anyone has a blinking LED at this point, let me know. But what should happen, as you can see on mine, your LED should still be on, but less bright than before. Less bright than before. Okay? Alright, so hopefully by now you have that set up. Who has the LED still working after this? Hands up. Who has it still on? Yeah? So everyone should expect the same result that I'm getting there. Right? What is happening is that the Arduino is processing so quickly for the human brain to see that it's turning on and off, on and off, on and off, on and off, and you won't even see that, right? It's too fast for us, right? It's doing millions of processes a second, right? Which means we need to now add some sort of delay to make sure that we can see that LED blink, right? And a very simple command we're going to add in, which is going to finish this code, and we'll try and finish one more before we finish up, right, is going to be called delay, okay? So type in the word delay, and type in any value you want for the delay, but note that the number's in milliseconds, okay? Note that the number's in milliseconds. On the back of this guy. Yeah. Okay, so the delay function will delay by a number of milliseconds. In this case, I'm going to put 1 second or 1,000 milliseconds. Okay? 1,000 milliseconds. Okay? Let's run that now. Okay, upload it to your board. Guys up the back, if you could just slide down a little bit. Okay? Now we've added a delay to our system. Surely now it works. Surely now it works, right? And what do you guys see on my screen? The LED is still on, okay? So, in fact, the LED has gone back to full brightness, so it hasn't even gone to half brightness like it was before. So, what is happening is it's running through this loop, it's turning it on, right? Waiting a second, then turning it off, but then it does the loop again, and it just turns it back on, right? So we never see the instance that the LED is off, and hence it's not actually visibly blinking, right? So we need to add one more command to our code. One more command here, okay? What you need to do is add another delay on the end of this program, okay? Add another delay to the end of your program, right? And what this means is it's going to turn on for 1 second, turn off for 1 second, and then restart and turn on for 1 second, turn off for 1 second. So if you upload that now, as I'm about to do here, okay, it's uploading, it's done. What you should notice now, if the live stream would update, give it a few seconds, what you should notice is your LED should now blink 1 second on, 1 second off. As you can see now, it's on my screen now. That's what should happen to your LED when you upload this program, right? And hopefully, all of this makes sense, right? Your LED is connected, right? And the LED is going to turn on for 1 second. It's going to turn it off, wait 1 second, and then repeat that cycle. Note how you can change the size of your delay to vary that on and off speed, okay? You can pulse your LED at whatever rate you want. but this is the simple program known as blink, okay? And all your LED should do now is do what it might have done at the start, and it should blink, but that's on your own control now. Now you have control over that blink command. Okay? We're a bit paced for time. We're going to spend another maybe 20 minutes on the next exercise, and then that'll be it for today. But we're going to come back next week and we'll do a bit more, alright? Is everyone ready for the next one? Yes? Someone who isn't ready yet? Some people who hasn't gone it to blink yet? Who hasn't gone it to blink yet? Alright, cool. So, let's make a move on. And I'm going to go to my slides here. Okay, we just made our first circuit and our first program blink, which is just turning an LED on and off. Okay, what we're going to do next, which is more fun, we're just going to now turn a button to control that LED. This is going to be pretty quick, okay, but I need everyone to follow up. Okay, this is going to be very fast paced. We're going to program, we're going to plug the button in, and we're going to get this all working within 20 minutes. Does that sound like a plan? Yeah? Alright, so you're going to need to grab your tiny button from inside your kits. Okay, I'll grab it from mine as well. What you'll notice is that your kit comes equipped with these colored little circular caps. These actually can be pushed onto the button, as is mine right now. Okay, I'll chuck one on the live stream here. And I'll chuck one on my hand, okay? So you can chuck a button on, you can chuck a cap on the button and it should look like this, okay? It has 4 pins, okay? What we're going to do is we're going to watch closely this diagram, and I want everyone to plug wires and resistors exactly as is. I'm going to first quickly explain what we're actually doing with the circuit, and then you guys can program, okay? So, what we're doing here is we're sending a signal, right, from 5 volts, which is going to be my power. Notice how 5 volts, which is my power source, is plugged into the red rail of the power, the breadboard. And from there, I can power one end of my button, one of the 4 pins, okay? It doesn't have to be both, right? It just needs to be one of the 4 pins. And on another pin, we're going to actually have 1 wire and 1 resistor plugged in. The resistor is going to go to ground, okay, just like we did for the LED. And the other pin is going to go to pin 10, okay? We're going to put it to pin 10 for now, just for the diagram's sake, okay? You can actually plug it into any of the digital pins when you get to it. Right? So, why we do it this way is because what's happening is we're getting a power voltage from this 5 volt supply, and it's being sent through the button, but because the button's not pressed, nothing can go through it because the wires are not connected. But as soon as we press that button, it closes the circuit and we get a bit of current flowing through the button and towards pin 10. As well, we have a resistor there to limit the current as well because the button can't support that much. Okay? And that's what's there, and that's what we're going to be reading. Okay? So, I want everyone to follow this circuit again, take a photo and so on. I'm going to show it on the live stream as well. So hopefully everyone has taken a picture of this. Okay? If you're on here in the workshop, you can refer to this diagram. It's very good. It's also in our slides for those in our live stream later on. If not, I will now show you how to do it on my hands on them. All right? So, has everyone got a photo of it? Has everyone got a photo of it? Or the slides up? Alright, cool. Slides gone. Here we go. So, live stream, hopefully everyone can see. This is going to be a little bit tight. Hang on. Alright. Alright, so can everyone see from here? Yeah? So, your button, notice how your button has a little notch in the middle of it, okay? That notch actually goes in line with the center hole of your breadboard. Okay? So I want you to slowly insert it, but line up that notch with the middle rail, okay? And that rail is designed for these buttons. So just press it in. What should happen is all 4 pins of the button should sync into 4 pins on your breadboard, 4 separate pins, okay? And they're all separately connected in terms of electricals, okay? Should look something like this, okay? It's pretty hard to show here, but that's pretty much the gist. It should fit. Like so. Needs a little bit of force, so you might need to push the button in. If it doesn't push and sink into the breadboard, then that means it's not all the way in, okay? The next thing we're going to do is we're going to connect the 5-volt plug to 1 pin of the button, okay? So grab some more jumper wires, okay, and that's these wires with the pins on the end. Let's grab more of these wires. I'm going to try and use different colors because otherwise you're not going to be able to see. So let's maybe grab a little bit of green, we'll grab some yellow, and we'll grab a nice black one too. Okay? So, what we're going to do is we're going to plug the pin 10 of your Arduino. Remember that mine is on a Mega, so it might look a little different. Plug pin 10, right, to one end of your button. Pin 10, okay, to one end of your button, like so. Okay? On the same rail that you've just plugged that pin into, we're also going to plug a resistor, another resistor from the same as the LED, okay? Another resistor that goes from that same rail towards ground, right? Remembering that ground was just that black rail, that blue rail we had before. So what I'll do is I'll grab another resistor from my little pack here, if I have one. Okay, I'll just grab a new one now real quick. We'll grab a resistor and we'll chuck it into from the pin that's connected, that we just connected before, next to the button. And the other one is to be connected to ground. So you guys remember how to plug it into ground. We can either plug it straight to the blue line as I've just done, which you guys will see in a moment. You can plug the resistor, the other end of the resistor, straight to the blue rail, or you can connect it to the other pin and then have another wire go as the diagram showed before, okay? As long as that resistor is connected between one end of the button, right, with the wire coming out as well, and the blue or ground rail of your Arduino circuit. Lastly, we're going to need to connect the power for this button, which is from the 5-volt pin on your Arduino, which you should see in the power pins, okay, from the 5-volt button, which should be near your ground pins, by the way, in case you're curious. The 5-volt pin to the other end of the button, okay, the other end of the button. So we're going to plug that in. Like so, okay? And so what you should get in the end is exactly the circuit we showed at the very beginning. There is a 5-volt wire going between 5 volts and one end of your button. And on the other end of the button, you should get 2 components coming out. One is a wire and one is a resistor. The wire goes towards pin 10, okay? And the resistor goes towards ground. Okay? Has everyone finished that circuit? Okay? If you need help, what we'll do is we'll test our program. Okay? We'll test our program, and if it doesn't work, then we'll come over and check. Does that sound alright with everyone? Just because we're a little low on time, alright? So, if you manage to get that circuit, again, I'll just show it on here one last time for you. Okay? Quickly check that your circuit looks something like what I've just shown you. Okay? Quickly check that the circuit you've just plugged in looks something like what I'm showing you here right now. Okay? Alright. Having said that, let's get quickly onto programming. Right, we only need 10 minutes to do this program, and then we can all head outside and we'll have lots of pizzas, and you guys can get excited, I guess, for pizzas, alright? You guys have been doing very well so far. I know this is chaotic. Alright, so let's jump onto our program. Okay, so here we go. We're going to make a program very simple. If you press the button, turn the LED on. If you press the button again, if you press the button and hold it, it's going to turn on. If you let go of the button, it's going to turn off. Okay, that's all we're going to program at the moment. Remember that you can make any kind of program if you're smart, if you see and understand all these commands, you can design these systems for yourself. But we'll get into more of that next week when we have a little bit more time and hopefully more prepared for this. Okay, so what we're going to do is leave that aside. What we're going to do, okay, is remember how at the very beginning we had to define our LED pin? Well, we've got to do the same for a button because we just plugged in a new component. So, hopefully you can follow along from what I'm going to type here, right? So at the very top, we're just going to type hashtag define button pin, right? Which is the name of the pin for our button. And the other thing we're going to do is we're going to plug in number 10 because that's the pin that we associated with the button, right? Arduino pin 10, button pin 10, right? The next thing is very similar to what we had before, okay? Remember that we had to establish our LED as an output? Well, our button is very similar, except our button is not an output, it's an input, okay? Which means, and I'm just going to make a bit more space here, so I'm going to delete this line here. Okay? What we're going to do is we're going to declare our button as an input, right? So the way to do that is very similar to what we had above. We're going to write our command pin mode, and we're going to declare our button pin, right? Which you're going to type as button pin. And we're going to declare it as an input, which you just do all caps input, okay? And that officially declares our button as an input. In the same way you might declare any other component or pin as an input or output, okay? Lastly, we get to the main section of our code, right? Where we need to read the inputs of our our button, and output accordingly, okay? And so what we're going to learn is another of programming's great statements called the if statement, which we're going to get to very soon. Okay? So I'm just going to clean up everything. What I want you to do, and I know this might hurt you, but we're going to need to delete everything inside our void loop. Okay? We're going to write some brand new code that reflects this new program. Where you can always save as a separate file if you really want to keep the file. But remember that all this will be uploaded to Facebook once I get the files ready to go. Okay? So, right. Can we just quiet down just a little bit so I can finish this off? We have about 5-10 more minutes. Okay? So, in the void loop, what we need to do is we need to check. We need to check that the button is pressed. If the button is pressed, I'm going to turn my LED on. If the button is off, I'm going to turn my LED off. Okay? That's all our program is going to be. It's quite simple. Right? And so, hopefully you guys can follow along with me. But what we're going to write is what's called an if statement. So you see that I use a lot of if terminology when I said, if the button is pressed, then turn the LED on. If the button's not pressed, don't turn the LED on. So what we're going to write is exactly as I say, if, and whatever's the condition, so the tested condition I need to put is going to be inside those brackets. And the condition we're going to test is that, is the button pressed or not, right? Is the button pressed, right? If it's pressed, before we even write what's in the if statement, right, inside those little brackets, if the button is pressed, note how if I press enter there, it automatically creates this curly braces for me. I don't even need to do that, okay? Creates this curly braces for me. If the button is pressed, I'm going to turn my LED on. Now surely, all of you remember the command for turning the LED on. What was it? What was it? The command for turning the LED on? Digital right, yeah, so let's type that in. Okay, and we're going to turn our LED on, like so. Okay. Okay, now that we've done that, we need to write our if condition, right? There needs to be some sort of condition for which we turn our LED on, right? And that condition is going to be if the button is pressed, or in Arduino terms, if we can read a digital signal. So, what we're going to write in here is we're going to read a digital signal, otherwise known as, hopefully I got this right in my notes, digital read, okay? And digital read just reads the signal and outputs whatever it sees, okay, whether it's low or high, okay? Digital read has to read a pin, and that pin is going to be a button pin, right? Because remember that we're reading the signal from a button. Okay? That's all we need for that one. What we want to check is whether that signal is a high signal, a digital on signal, right? Which means that we need to check whether it's equal to, you guessed it, high, right? We need to check whether our signal is equal to high before we can actually output, okay? Before we can turn the system on. Now I believe there's a slight difference in the equal signs, which we'll get to in a moment, but that should be most of the code, okay? If the button is on, turn the LED on, but you'll notice that there is no code to turn the LED off. So let's give it a shot. Let's see if I made any mistakes once again. We'll press upload, and I'll go, oh, required left operator statement, right? So what this means is that this actually needs two equal signs. There's a huge explanation for why that's the case. Okay, but I want you to put that in first and I'll explain next week. Okay, this is all, we're out of time, so I don't want to explain it right now, but you need two equal signs for that. Okay? What you should notice is as soon as you upload the code, your LED turns off, like is in mine. Your LED is off. But if as soon as I press the button, the LED is going to turn on, right? Because that's what our command told us, right? If I press the button, turn the LED on. But you'll notice that LED is now on, but it's not turning off, right? And that's because our code hasn't actually told us to turn it off yet, right? So hopefully you guys can see that we need an off case as well. We need to check if the button's no longer being pressed, we need to turn the LED off. So let's do that, right? I'm going to do it the very easy way, and then next week I'll show you the slightly cooler way, okay? So, what we're going to write is, if the button is turned off, if, and then I'm going to type this with one hand real quick, digital, read, and you can just copy paste this from above if you want, button, underscore LED, is equal to, instead of high, we're going to check if it's equal to low. Okay? If the button LED is low, we're going to write a digital write. Okay? We're going to write a low signal to that LED. Okay? That logic should hopefully sink in that if I press the button, it turns on, the LED turns on. If I depress the button, so if the button's unpressed, it returns a low signal, and consequently I'll turn the LED off. If I now upload my code, here we go. and oops, I've made a mistake somewhere, I made a typo somewhere, button LED was not, it's not button LED, it's button pin. Notice my typos there. But note how Arduino will actually tell you those errors, okay? Upload, let's see if it works. And we're good. Right, so it should say done uploading, and here we go. What should happen now is if you press your button, your LED should turn on, but if you don't press it, it's going to turn off, right? Which is exactly what we're after, okay? This is the last bit of today, okay? So, just as a conclusion, okay, whilst everyone's copying that up, just a conclusion, thank you again to everybody for coming today. I know it's a bit paid. Next week, I'll see if we can get a much bigger space, okay, and we'll make this work, okay? I'll try to get a lecture room or something like that, nice and big with lots of tables, and we can all work and make our circuits much better next week, okay? Thank you again, everyone, for coming. Keep posted on our newsletter and our Facebook page. And lastly, all right.
Thanks for coming, guys. Let us know if you need help. Pizza is outside. Go crazy. And we're going to put dietary requirements pizzas on the stage here. Thanks for coming and chat to us about anything. We've got a few projects happening and yeah, it's all good. See you next week.
Thank you very much, guys, and I'll see you next week. And if you're still trying to fix your button circuits, I can still help you fix it. Yes?
Do we have to take this off? Daniel.
Yes. That shouldn't happen unless it's a 10 pitch, because connects generally are not good. So I think that's just a tiny bug that you might notice, but generally comments don't do anything other than take space. So yes. That just means that that variable or constant hasn't done the job. So in the case of this, if I don't write find the button before using that, then you're going to get down 0 to 5. So that's why sure is 5. Yeah. Cool. Sorry.
I don't know what flavors these are. I forget what I'm
This one I think is to store power because it doesn't store much power. Usually when you have resistance, you want to stop the high voltage to be
Green is positive, which goes to 5 volts. That's correct. And 5 volts goes straight to 1. So you're plugging it too far out.
I think that's
Yeah. Oh, and you see that's what it is now.
I don't know.
Yeah. No.
What do you want?
I'm
mean, there are. But
So as a medicine, not the correct. So just means you have one kind of whether it's a constant or variable species, you have to make sure that otherwise, Arduino won't know what button it is. You've got to that's what I'm saying. But anytime you run into any of these issues, just do a quick research code, and it will usually tell you where you have you've gone into like the final variables. No worries. No worries. Alright, fingers crossed. I think we have a cable on the front here. Sorry, my hands are thank you. Yes, another code brace. Let's see. Yes! Yes, it works! Awesome! There you go. Excellent. Anyone else need some help before I wrap up?
Yes, that would be nice. So it's good website.
But they're very much like really deeply monetized. No idea, but not for me, there are reasons, and I think your friends are really good at it.
Yeah, there's one friend who probably knows exactly what you're talking about.
Yeah, so just to mention it, the minions are not like Freddy and that's not but they'll be there's a bit of delay because I'm really tight right now. Yes. You don't need to but everything else is So you notice that there, it's plugging into the wrong rails inside here. Can you see that? It's plugged to the wrong rail. Yeah, can you see it? Change that and it should work. Give it a shot and let me know. Yeah. Subcommittees, yes. Were you the person last night like 11:30 by any chance?
Yes.
Something like that? Yes, okay. Yes, so might have a quick chat as I start packing. But yeah, so were you interested in any particular sort of, I guess, ideal?
I tried with you.
Did it work?
Yeah, I changed
No. Didn't it work? Sorry, I'm just going to stop this real quick.